All right. Hello, everyone. Welcome to today's webcast. It is 12 o'clock on the dot, so we'll go ahead and get started. Today we are going to be talking with Kim Grove from the Baltimore City Department of Public Works about better bacteria investigations. So a couple of reminders for folks who maybe haven't joined in a while or are taking their time at home to join us maybe for the first time. Welcome to the webcast. We do have two quick poll questions at the beginning. Just select your preferred option. I don't think many of you, if any of you, are probably viewing alongside of your colleagues today. But if that is the case, just answer in the manner that represents your organization. We are recording today's session. So hopefully, if you like it, you can share it with your colleagues if they weren't able to catch it today. Or if you have to drop off early, I know folks are juggling a lot of things as they're working from home, so feel free to download it later. We will get it up by hopefully before the end of the week. And we do appreciate your feedback. We have a short survey evaluation. It's only 5 questions. It'll take you less than a minute to fill out, but we do appreciate it. Our funders like to hear that we're doing a good job, and we like to know what we can do to make these webcasts better for you all. Finally, not on the slide, but just a reminder, we will take questions. We'll have a Q&A at the end today, but please don't feel like you have to wait until the Q&A to type your question in. If something pops into your head throughout the presentation, go ahead and type it into the chat, and we will get to it at the end. Just a couple things that are new at the Chesapeake Stormwater Network. We have 2 reports that have been put out in the last maybe 2 weeks or so. The first is a memo with new guidance for improving the prevented sediment protocol for stream restoration projects. For those of you who are familiar, that's Protocol 1. There's a lot of really good new information to try to make sure that there are better stream restoration practices being implemented. Things like ways of better clarifying what is bank armoring, which is something that we're trying to avoid, too much rock, basically, just to protect the banks rather than implement comprehensive practices that are going to provide a benefit to the ecosystem in addition to your nutrient and sediment reductions. Also new guidance on monitoring methods and approaches and ways of standardizing some of the bank erosion rate measurements that folks are collecting. So if that's something that's interesting to you, you can check that out. And we also have a webcast covering it, which I'll mention in a second. The second report is on climate change and stormwater. From stormwater stakeholders' perspective, we put out a survey a couple of months ago. I guess it was last fall now. We compiled all those responses. We had over 200 responses from around the watershed, from across different sectors of the stormwater community, telling us what their biggest concerns are around climate change and stormwater management, as well as some of their current management practices and what they need in the future. So we have a summary report on those findings out now. It is part of a 4-part memo series that we're going to be rolling out over the next year, addressing climate change and stormwater management. As far as upcoming webcasts, we have 1 open for registration now. The second one will be up for registration in the next day or 2 on April 9th. This is the one that you can register for right now. We have the new guidance on the prevented sediment protocol, so the memo I just mentioned. 2 of the members of the group that developed that guidance, Josh Running from Stantec and Lisa Fraley McNeil from the Center for Watershed Protection, will be joining us to talk about that memo. And then on May 14th, we're doing a collaborative webcast with the folks that develop CAS, which is a Chesapeake Assessment Scenario Tool. It's essentially the Chesapeake Bay watershed model that users can use to plan their projects for TMDL, nutrient and sediment reductions. So if that is something that is of interest to you, modeling practices, we're going to be walking through how to do that specifically for stream restoration on May 14th. So registration, again, for the April 9th webcast is up now, and the May 14th webcast will be up in the next day or 2. All right, so we'll go ahead and get to our polls. I'm going to go ahead and launch both of those right now. The first one is just letting us know who you're representing today, whether you're with the local government, private sector, regulatory agency, state, federal, local, NGO, academia, or other. And then telling us how many people are watching today. My slide usually has a bunch of options that go up to 10 plus people. Given the circumstances, I have only given you 2 options, which is just you, or maybe it's 2 plus, but you have to be more than 6 feet apart per the CDC recommendations. Hopefully you all are able to stay at home today, or at least be in a safe place. You also can feel free to count your spouses, children, and pets if that makes you feel better about your group watching. All right, so we've got a pretty good mix today. I'll go ahead and close that. Thank you all for filling it out. Okay. So what I want to do next is just quickly set the stage before I turn it over to Kim. So basically the issue of bacteria management was something that CSN was asked about a couple of years ago. Back in 2018, we had a stormwater forum in the DC metro area. And at that forum, some of the members, as well as our urban stormwater work group, requested guidance on a couple of different topics, including land use loading rates for bacteria, source analysis techniques, and how BMPs do at removing bacteria from surface waters. So we put together an ad hoc team to do a literature review and summary report, which you can find on our website. A screenshot of it is on there on the page right now. But basically, I just wanted to kind of touch on some of our findings because I think it's a pretty good segue into what Kim is going to be talking about today. And a lot of this, I think, you all who work in bacteria management probably already know, or at least anecdotally are familiar with, but was definitely confirmed as we look through the literature. And a lot of that is site specificity is really important for bacteria management. Watershed conditions are really unique, especially when it comes to bacteria, and so loads are highly variable. So it's very important to know what's on the ground in your community rather than making sort of larger generalizations. And so, along those lines, when it comes to, accounting for bacteria reductions, if it's under a regulatory framework or something like that, it's difficult to kind of set something up the same way that we do for nutrients and sediments. There is not really any support at this point for loading rates for fecal indicator bacteria based on monitoring data. So, you can't say that we have, a certain number of colony forming units per acre of impervious cover or acre of row or turf grass or something like that. It's too variable across the landscape. And similarly, BMP removal data is highly variable as well. There's a couple of BMPs that show some promise as far as providing reductions in bacteria, things like bioretention and some constructed wetlands, but there are a lot of site-specific factors that go into how effective those are, and field studies can show anything from almost 100% removal of bacteria to your green infrastructure practice actually being a source. If, for instance, geese land on your wet pond or something like that, and you have an actual input going on. So the dynamics make it really difficult, and so monitoring is still going to be really important. It's really a combined approach that is still sort of best practice. There are still a lot of information gaps about seasonality. Dry weather discharges can be really spotty, as you know, and so sort of a combined approach, looking at source targeting. Maybe you throw some BMPs in there, but they're probably not going to be doing a lot of the heavy lifting, and then you're monitoring. And so that sort of brings us to our topic today, and that's really doing our sleuthing for bacteria sources. A lot of them are hidden in your existing infrastructure, so you have to do a lot of work to identify and track the sources for the biggest impact so that it's cost effective and also providing the health, public health benefits that you're looking for. And so I have seen Kim give a version of this talk before and was very excited to have her on to talk about what they're doing in Baltimore City with regards to bacteria monitoring. And so I'm going to go ahead and introduce Kim now. Kim Grove is a professional engineer whose 20+ years of experience has spanned the spectrum of civil engineering, including stormwater management, land development design, environmental site assessment, remediation, geotechnical engineering, and forensic analysis. construction management, and materials testing. A graduate from the Florida Institute of Technology, Ms. Grove spent most of her career as a private engineering consultant, working throughout the Southeast and Mid-Atlantic region until she joined the Baltimore City Department of Public Works in December of 2010. Ms. Grove currently serves as the chief for the Office of Compliance and Laboratories, which is committed to enhancing environmental regulatory compliance for the department through collaboration, management program improvements, and regulatory enforcement. So I'm very excited to welcome Kim, and you can go ahead and take it away.
All right, thank you very much. And good afternoon. Thank you for taking the time to listen to this presentation on Baltimore's approach to bacteria monitoring and investigations. David, how do we go back up? There we go. Okay. So just a few basics about the city of Baltimore. We're over about 500,000 people, but we're squished into an area that's only about 82 square miles. It's about the same size as Washington, D.C., but only half the size of what you would see with Philadelphia. And we have a lot of impervious area that was pretty much built out in the 1950s. And what that also means is that any of the pipes that we have underneath of our ground was also installed prior to the 1950s, the majority is. We are part of the Chesapeake Bay watershed, and we have 5 watersheds, 4 of which we share with Baltimore County. 3 of those we are receiving stormwater from Baltimore County. The other one, we give it back to the county. We do have a completely separated system, which is rare for a city this age on the East Coast. And we've had our MS4 permit since 1993. We also have a consent decree related to sanitary sewer overflows since 2002. And since I had mentioned that we did most of our build out in the 1950s prior to the Clean Water Act, a lot of our stormwater best management practices that would have been installed related to development, they're just not there because they weren't required at that time. Bear with me, there we go. So when we talk about bacteria TMDLs, David had mentioned that there are a lot of best management practices that can be available for it, from replacement of your sanitary sewer systems to doing preventive maintenance. There has been some research related to stormwater BMPs and whether or not they decrease or increase some of the bacteria. Septic system improvements can be very helpful, but I can tell you that in the city of Baltimore, we don't have a lot of septic systems. Education is a really key part because bacteria, very similar to trash, has a social element to why that is a pollutant source. But today, I am going to focus on illicit discharge detection and elimination. The city has at least 4 TMDLs related to bacteria. We are probably going to be having another one come in for the bay, for the harbor, but since the harbor is the tidal area which is receiving waters from the Jones Falls and the Gwynn Falls and lower North Branch Patapsco, they have just focused on they've only issued the TMDLs for those non-tidal areas. And the numbers are big, but what really you have to focus on is in those TMDLs, especially for Back River, Gwynn Falls, and Jones Falls, we're looking at a reduction between 96% and 99.7%. So within the city, we have a lot of pipes. If you recall, I said that we were about 82 square miles, but collectively, we have almost 4,100 miles of drinking water, wastewater, and stormwater pipes crossing underneath of our streets. So it's a very high density of pipe networks, and most of those pipes are past their life. So they're in bad shape, they are leaking, or they're having enough cracks or separation at the joints that they're allowing for infiltration to occur. For the City of Baltimore, and the Department of Public Works is a local government agency that acts like a regional utility. On the previous slide, I had noted what we have for pipe networks within the city, but we're also responsible for the drinking water distribution that extends out to the counties, as well as providing drinking water for other surrounding counties. And then on the sanitary system, we operate 2 wastewater treatment plants. So our collection system is not only what is within the city, but also what we are collecting from the adjacent counties. When it comes to IDDE, there are a lot of sections and divisions within the department that assist with the IDDE program. My department, my Office of Compliance and Laboratories takes the lead at the beginning and at the end, meaning the detection and then the verification and elimination. But along the way, the Bureau of Water and Wastewater Utility Maintenance Division, the Office of Engineering and Construction, and the Office of Asset Management work together when we have to focus on that elimination part. And then if the source of the illicit discharge is coming from a private property, then our Office of Legal and Regulatory Affairs may come in to assist with the enforcement of local laws that allow us to get a closer remedy. There is also a Department of Housing and Community Development, which is responsible for the plumbing codes and can also have authority to go onto properties. So they will assist us at times if we are dealing with private property owners. So it's not just about the pipes, it's also about the people when you want to talk about how you want to develop a good IDDE program. Specifically within the Office of Compliance and Laboratories, the Water Quality Monitoring and Investigation section is responsible for IDDE. It's 13 positions that are scientists and engineers. We have a $2.2 million budget that is funded by the water utility, wastewater utility, and stormwater utility. And within that budget, it's mostly focused on operations, but we do have certain partnerships and volunteer programs that we assist. An example is some of the research that I'll be talking about later on related to microbial source tracking. The bulk of our efforts go into a weekly screening program that we have at 88 locations where we monitor for the water quality indicators that are listed there on the right. But in addition to that, we also do a monthly stream impact sampling. In the spring, we'll do a biological assessment. We do have to respond to our non-emergency requests related to polluted waters. As part of our MS4 permit compliance, we have to sample during storms. Related to our consent decree for SSOs, we do confirmation of abatement as well as large SSO sampling. On top of all that, this office is responsible for a flood alert management system of several gauges, stream gauges, and rain gauges throughout the city. And we also provide education through our public school programs. So the history of IDDE. We've had our MS4 permit since 1993, and in that first generation is where we first started to do it. When we do the investigations, we call them pollution source tracking investigations. That's the PST. And in 96, with paper maps in hand, we set out to do it. We were also working with the Center for Watershed Protection and trying to develop certain protocols for working. But one of the biggest issues that we had is taking the sample and then having to take it back to the lab to get it tested, find the result, and then trying to backtrack through the system. That's way too many steps. So in 1998, we modified our protocols so that we could really focus on just using field tests that could be done. And so in addition to temperature, pH, specific conductivity, we also added in chlorine and we added nitrogen ammonia as our field tests. In 2002, when we were issued the consent decree, that sparked a digitization of all of our plan sets that showed all the pipe networks. So again, that is over 4,000 miles of pipe networks being digitized within GIS. But what that allowed us to do is to create an application on electric laptops or notebooks. So instead of having to carry out all the various plan sets or maps, now we had something that was a little bit more useful in the field. It wasn't perfect. The notebooks were still very heavy. Any data that was put in still had to be downloaded at the end of the day. So it was a good step forward, but it wasn't perfect yet. In 2014, we reorganized because one of the issues that we had was that the Water Quality Monitoring and Investigation section would identify the location, get it to a certain point, and then hand it off to another group of engineers and contractors to try and finish that work. So the prioritization may not have been staying as high as it wanted, and we started to see a large lag time, especially for small discharges, but that were continuously happening for a long time. So we reorganized, and we also added a 311 service call within fiscal year 2014. Then, if you notice on this history, every year we were doing something new, either a new technology, like putting an application on an iPad, which was much more real time, adding more types of cameras for our staff to use. In 2017, we added an optical brightener piece of equipment so that could add as a supplement, because sometimes illicit discharges from a sanitary system or related to a sanitary discharge is not always about bacteria. Sometimes it can be related to detergents. And then finally, in 2018, we started our microbial source tracking study. So our investigations, by and large, are started because of our routine sampling. And in the Chesapeake Bay program expert panel on IDDE for gray infrastructure, when they talk about an enhanced IDDE program, they really want to see something where you're not reacting to a response from a complaint, but that you have a systematic methodology for detection. And as you can see, we've done over 2,000 investigations since 2008, and the vast majority of them were started because of our program. And about 48% are done within 1 day. So when we have to do an investigation, a lot of times, because we have our protocols set, we can identify the source within 1 day. But I do want to let you know that 30% usually stop or no source is found. Not every investigation is going to end up where we can find it. And we average right now about 180 investigations per year being performed. So that, in addition to our routine sampling, we have a dedicated group of about 5 field scientists who are routinely staying focused on these investigations, plus an engineer who can help work through what the revenues may be. And so these are just some of the statistics coming off of our hotline, or 311 for polluted waters. And what this all comes down to is about 1 in every 20 calls that we get may actually result in an illicit discharge being found. And I just want you to note how few complaints we were seeing in 2019. Keep that thought in mind, because we're going to come back to it later on in this presentation. So our PST applications, there's the protocols, there's the thresholds we set, there's the tests that we do, but I have to say that some of the most major advances have come because of the technology we have used in trying to record our results and then being able to access those results and any other supplemental information while in the field. Our previous notebook setup had just a static set of GIS data, so that if we found any discrepancies or if anything changed in the GIS, we didn't have those updates. We also couldn't see other information where construction may be happening or a turnoff might be happening. So now that we are this new application, we can connect in the field with our utility viewer. We can put a lot more information. We can call up old information. And most importantly, any of the data that we put in is real time. So it's transferable. So if a team has got to take it over to another team, that's great. The team is also able to use other applications such as FSO reporting. So technology is a really key factor in the success of our program. So this is just a quick snapshot of how we backtrack within the system. On the left, you can see the layout of all of our routine sampling locations. We have about 88 ammonia screening, and some of them are in the stream, but a lot of them are at the outfall and may even go up into the system for a weekly sampling. So the way it would work is you would start at the outfall, and we use a threshold right now of 0.3 milligrams per liter for our ammonia nitrogen as a threshold to start an investigation. So for this one, it's 1.2. We'd go upstream into the system. It's no big deal that concentrations may increase because the base flow may be a little bit lower. So we would keep tracking this up, but if we went north, saw no base flow, obviously that's not where our illicit discharge is coming from. If we went to the west and found a lower ammonia reading, that's not where we would go. So if we headed east, still seeing it come up high, that would be making sense, but heading south, still that would show us that the illicit discharge was not coming from the south. We would then move north and see a very high discharge. It would say that we're getting closer. Going up one more part, we would see that, oh, that ammonia has come down. So then that would identify that that manhole is our hot spot. That is the area that we would want to concentrate. And this type of backtracking and looking at the ammonia screening, we call this a phase 1 of our pollution source tracking. And we would then move into a phase 2, which is a visual assessment tool. Now, all of our pipes are not large like the one that I'm showing in this photograph. We do have some that are 5 to 10 feet large, but we have a lot more that are more of a 5 to 3 foot in size. So when we're doing our dye testing, we will employ a lot of different types of cameras to use to be able to see when and where that dye is coming into the storm system. And then if we can, we work with our utility maintenance division so that they may CCTV the sanitary system to see if there's any cracks or anything within that sanitary system. A traditional dye test would be done where you would deploy the dye into one manhole, you would wait, and then hopefully you would see it show up in the storm manhole downstream. However, what that does is it just allows you to see that the dye going across that length in between those two sanitary manholes, that's where it's coming from, but you're not quite sure where within that 400 length you may be seeing it. And what we started to see is that if we just said it was a segment in between the two manholes, the cost of that repair was pretty high. So we tried to look at different ways where we could pinpoint it down to only a small location and get a one-point repair. If you're lucky and you're able to do the CCTV and you can find that crack, it's easy to identify the one-point repair. But there are times where the crack may be submerged with the base flow within the sanitary system, or it may be minor and not able to be picked up by the CCTV. So that's why we started to look at different alternates. And this is one of our great low-tech ways of doing it. Instead of just pouring all of the dye, we have created almost a tea bag of dye solution, and we attach it to an empty bottle. And then what will be done is we will pull the bag along, wait about 5 feet, wait some time, see if we're seeing any dye, pull it another 5 feet, and then keep continuing on until we get to a point where the introduction of that dye within the sanitary system starts to show into the stormwater system, and that helps us to pinpoint where we should be looking for the break within the sanitary system. And this is just a visual of how that tea bag looks. We've also developed a very low-tech dye diffuser, which allows for us to introduce dye within the manhole if you've got it if you've got multiple ways for the sanitary system connections to be happening. So another alternate that we've had to employ is actually a mass dye. And this particular time, we had an introduction of illicit discharge within the stream, and it wasn't coming from the adjacent pipe. So we had to do a mass dye deployment from certain locations to finally understand that the break was happening further up in the system, but it was coming through the underdrain within the sanitary system. And then another alternate that we looked at is this scenario where the adjacent sanitary system next to the storm system was not the part where the illicit discharge was coming from. It was actually further, it was from a concurrent sanitary system or a parallel sanitary system, but it was almost a block up. So there will be times, so what we had to do was introduce the dye and then keep a flow monitoring camera to wait almost 24 hours to see when that dye came in. Because what was happening is there was a break within the system, the sanitary system. It was coming through some of the gravel that is under the underbed, and then finally connecting into the storm drain system. And when you're in an urban area with so many different pipe networks, that gravel bedding really plays can a confusing complication in trying to backtrack where your illicit discharge is coming from. It almost mimics a karst terrain. So this is one last case study that we had. This was in a downtown area of the city. We had been doing, in addition to our routine sampling, we had been doing outfall sampling along the harbor and saw very high ammonia nitrogen levels. So we backtracked it a couple of blocks, but we did the dye testing just within the public system. We couldn't see any introduction of the dye, but the ammonia levels, and we also had it verified with bacteria tests, were showing that there was some type of sewage that was coming into our storm drain system. So this investigation took several weeks. It was very complicated because you're in the downtown area, so the maintenance of traffic was difficult. There was also a lot of different, even though the services may be one or two services to the building, there were a lot of different storefronts and such and fixtures that could have had that introduction. Long story short, on this investigation, what we found was it was actually an apartment condominium, high-rise condominium, and a quarter of the condos had their plumbing system connect into the storm downspout. So you would have never seen it in any type of connection to the main part of the storm drain system. And the only way we found it is that we thought to not just introduce dye at the base level, but to try various apartments within that high-rise. So finding the source of your illicit discharge is one part, but that's almost the easy part, especially when I showed you that the data, a lot of times we can find that source within one day. And when we backtrack that source to actually being on a private property, that's where things really take a different turn, and communication starts to become our greatest tool. Usually we'll go through the routine of notification, starting by, and then educating before we go into enforcement, and then abatement. But that communication has to be, you have to be ready to have communication in several forms, through email, through person-to-person talking, phone calls, direct mail. And at this point, that means also that communication will likely happen outside of the normal work hours of 8:30 to 4:30. If you're lucky, just the notification can go to abatement. But I will say that through our experience, we find that education and enforcement, more education tends to be effective, and then finally the enforcement side of it. But the reality is that a lot of pollution source tracking is not one source only. This is a picture of a hydra, which is a mythical creature where if you cut off the one head, more show up. And my team feels like this is their spirit animal. So this is a case study just to prove that point. This was an illicit discharge of sewage that we were finding in our stormwater system. It was associated in a residential area, single-family detached home. When we did the dye testing and then CCTV, we had realized that the public side of the lateral, sewer lateral, was cracked and needed to be repaired, so we repaired that part. But then we were still seeing high ammonia levels, and we had to work with the property owner, introducing dye over a long period, as you can see in that sink, to be able to demonstrate that there was some type of release coming from the private side of their lateral. And this was also very difficult because their plumber was showing that he had CCTV'd and he was not seeing any large cracks, but dye tests were showing a different story. What we were also noticing is that the dye wasn't coming in through our storm system through any kind of crack within the storm system. Instead, it was releasing to a downspout connection, their private downspout connection. This took a few months to remedy, but I will say that the continued communication with the property owner really paid off for us. So there will be times when we use all the tools in our toolbox and we're still not finding the source. And this is when microbial source tracking has come into play. We have been working with the University of Maryland, Baltimore County, as well as the University of Baltimore in trying to do this work. What we have recognized, though, is that microbial source tracking isn't your step one. It's not even your step two. It should be used when you've exhausted everything else. What we did was we started to compare some of our known samples and also some of our locations where we knew that there was no sanitary sewage coming in to try and establish what we wanted for a threshold. And for us, we used the human markers being at less than 1% to say whether or not we would continue an investigation. Through 2 fiscal years worth of sampling, we were actually able to stop 14 of our 20 PXT investigations just based on that threshold. But there have been other times where the data came back and we could see that a large portion of the bacteria that we were seeing was related to canine. And so that enabled us to say, okay, we need to stop searching at the sewage and we need to possibly look at education related to pet waste management. So these are the results, and these results can be found in our MS4 annual reports that are posted on our website each year. As you can see that our pollution source tracking doesn't just find illicit discharges related to sanitary sewers. It also finds discharges from our drinking water systems that have not erupted at the ground surface yet. And so just for certain acronyms, if you are not in Baltimore City, the term SDUO is a sanitary discharge of unknown origin. This is anything that it's not evident that it's coming from the public system, and all of our private discharges get classified as SDUOs. And then this also is listing any of our dry weather SSOs. A lot of these are more related to exfiltration from the sanitary system. So the overflow isn't showing on the ground surface. Instead, it is discharging directly into our storm drain system or into our streams. Now, because we are in the Chesapeake Bay watershed, we have used the expert panel recommendations to take some of the results from our IDDE program and translate that into a removal or reduction of nitrogen or phosphorus. When we did that, we only focused on those discharges that we found from either our routine sampling or our special studies, not anything that was a complaint response. And we really focused on the large discharges that we found for sewage exfiltration or drinking water transmission, plus any of the sanitary direct connections that we were able to find through our program. But at the end of the day, we have to come back to why are we trying to do this? And we are trying to get a reduction in bacteria so that we can eventually use our waters for swimming and fishing. So within the state of Maryland, there is criteria set related to your fecal indicator as well as water quality indicators. And this is just a sample of what we include each year in our annual report. Unfortunately, I can't say we're there, we're ready to recreate yet, but when we have also evaluated our bacteria data that we collect as part of our stream impact sampling, we can see that at certain locations, we're headed in the right direction. And this has been a way that we have shown our data in the past, and it is pretty easy to consume and understand. However, it doesn't quite allow any decision makers to say, well, what is the next step? Or what could we possibly be doing? What is making this happen? Because you're condensing all of your data for 1 year into one bar for one sampling location. So if you recall when I said those customer service requests for 311, pay attention to 2019. And 2019 was the fiscal year of 2019 was a really big deal for us. The calendar year of 2018 was actually the wettest year on record for the state of Maryland, which was almost 20 inches more than our average rainfall. But when you look at the fiscal year, and for the city of Baltimore, that is July 1st to June 30th, it actually shows that the fiscal year of 2019 was the really large rainfall. What I'm showing here is a comparison of a weather station for the National Weather Service and what we have for rain gauges in 4 of our gauges from our flood alert system. And the big takeaway from this is the variation that you can see within the city. Again, only 82 square miles, basically 9 miles by 9 miles, and yet we are still seeing almost 11 inches variation in some of these stations for the entire year's rainfall. Even more so is to look at the number of days where we had rainfall over 1 inch. So for folks who tend to do stormwater management design and are creating controls for quality control and they're designing it for the 1 inch, when you start to see that more than 20% of your rainfall events are greater than the 1 inch, and I can tell you, if we dug even deeper, that's 1 inch in 1 day. A lot of those rainfalls were happening 1 inch within 45 minutes to an hour and a half. It starts to make you wonder how effective that qualitative control may be. Really, for this purpose, what made me realize was that when I want to look at rainfall data, I might want to go a little bit more localized to where I'm seeing the result rather than staying with a national weather station, because in an urban area you can see that much of a variation. And so this is just one example that we are starting to, one way that we're starting to look at our data. It's that same watershed that I was referencing before. This is Gwynns Falls, and it's the stream impact sampling data. But instead of trying to show each of the sampling locations separately, what I'm showing is each sampling event and how there might be variation within the bacteria results, and then trying to compare that with the rainfall. Now, bacteria is not solely related to rainfall. In fact, there's a little bit of a balance, because depending on how the rainstorm is happening, you may have more introduction of bacteria because of the sanitary sewer overflow, or you could have a greater dilution. So the next part we're going to bring into this evaluation is any of the reported SSOs. We have that data for the city, but I also need to get the data for the county, because for this watershed, it has a significant amount within the county. So the final thoughts that we have. IDDE is a fantastic practice to use if you are trying to reduce bacteria within your waterways, especially if you have evidence that the bacteria is related to sewage or humans. But I'm going to say, think outside the pipe. There will be times where it's not always your closest pipe that is your culprit. And I definitely recommend to find your inner MacGyver, because every solution does not have to be a high-tech solution. There's a lot of low-tech solutions that can be available that can get you your answers. Along the entire part of the process, communication is a vital tool. And once everything is, want to look at how successful your performance may be, how you may visually demonstrate it, it should be considered. And I would really welcome any collaboration of other municipalities or consultants that have started to look at those results and would want to think through of different ways we can evaluate it, because this is not, when we're talking about a performance of how we're doing with a TMDL compliance, this is not going to be the same way that we would look at something like nitrogen or phosphorus. And that's why it's important to consider more than just the test results of bacteria when we are trying to evaluate our performance. And so with that, I think we're ready. We've got a few minutes available for any questions.
Great. Thanks so much, Kim. That was a really good presentation. We do have one question in already, and folks, if you do have questions, go ahead and you can start typing them into the chat box. The first question that we had was sort of whether you had any data available that sort of indicates what portion of your total bacteria load comes from those illicit discharges. I think sort of getting to the point that, you know, whether you're seeing lower surface water loads or, you know, numbers after you go and eliminate some of those illicit discharges. Do you have any data on that and sort of how you strike that balance?
I think so the thing is that much like that little hydra animal, I wish I could say once we're in an area, we take care of that illicit discharge, we'll never see a problem in that area again. It's just not the case. Sometimes what we'll see is that you just push where that release is coming from somewhere else within the system. What might be a helpful reference is we do have all of our microbial source tracking results in our annual reports for 17, 18, and 19. And what that helps us to demonstrate, not just do we keep doing a PST investigation or not, it does help to demonstrate if there are certain areas where it's just not sewage related. The other thing is that for us to say the bacteria results are just from illicit discharge, well, I guess you can say yes, it's an illicit discharge, but whether or not we've reduced it because of the IDDE program as opposed to the capital improvements we're doing with our consent decree, because it's so complicated, it's not an easy one for us to say, yes, that bacteria definitely came down because we found that one, we solved that one right there. What's the next question?
Great, thanks. Yeah, looking at some other potential strategies, there was a question about using street sweeping programs as a bacteria reduction strategy. Has Baltimore City, I know you have a pretty advanced street sweeping program. Do you look at it for bacteria reductions, or do you look at it mostly for sediment purposes and trash?
So I think that common sense would say, yes, that's likely to happen. So a lot of times where we see bacteria, we also see high nitrogen. That's why we use ammonia nitrogen as one of our indicators. And in our other data, what we have noticed is that when we started to do street sweeping and we took it citywide, we saw a marked decrease in our total nitrogen loads within the city. But we've not dug deeper, and we have not conducted a study related to the bacteria loading. One thing that we are interested, though, in, and this has come from microbial source tracking, is could a rat population also be a factor? And so if we have proactive rat abatement techniques that are happening in certain areas? Are we also noticing a decrease in bacteria around those locations?
Great. A question about, do you use sandbags in your pipes? And then as a follow-up, how detailed are your SOPs?
Do we use sandbags in our pipes? No, we do not do that. And how detailed are our SOPs? So we have several SOPs that we have written and that we go back about every year or so to do. We've got ones that are related to just conducting the ammonia screening or the SIS, the actual field protocols that we have to do, and then also how we are managing our data.
Thanks. This question sort of gets to something that I sort of alluded to earlier in our review that we did at CSN of sort of land use loading rates and things like that. You know, the IDDE program works really well for identifying illicit discharges, obviously, in, you know, sort of the piped system and things like that. But have you done much in the way of sort of tracking sources to, I guess, surface areas like landscapes, lawns, you know, locations like that? And is there sort of a different approach that you take if you suspect that a source might be, like you mentioned, a pet waste source or something like that that comes from lawns, or are you still focusing on those outfalls?
So when you have such a dense pipe network, that's like having a whole bunch of streams underneath of your streets. Trying to see if I'm understanding your question correctly. We've really been concentrating on the illicit discharges if they are coming from a pipe network. I don't think I'm understanding your question quite correctly.
I think it's really I think the question was really just getting at, you know, whether you're seeing high bacteria concentrations just about everywhere you look, was sort of the way that it was phrased, including landscapes, lawns, stream bed and banks, street gutters, places that maybe aren't traditionally connected to a specific illicit discharge. So,
no, no, we're not seeing anything like that. What we do, we have certain hotspots, though. We have certain drainage areas that we do tend to see. I mean, even that one, I'm going to go back a little bit just to demonstrate this. So even on here, this is a bacteria, and for fellow scientists, I'm already going to apologize that I've got the bacteria listed as a regular scale, not a logarithmic scale, but you can see that two particular outfalls have a significantly higher bacteria level than what we're seeing in the others. We do have certain locations, because we use ammonia screening, we do have certain locations that just historically have, just right off the bat, high levels, and others where it's a little bit less on the ammonia screening. But trying to say that I can relate it to what the land use is, it's not as easy. What we've been noticing, it's really more about the pipe, the age of the pipe, as well as the human behavior, and, you know, are people flushing the right things, whether it's fog or white, and how is that relating to SSOs?
Great. I guess probably related, a question about dog markers. How often you sort of find those dog markers as an issue, you know, whether you have those hot spots, like you mentioned, near dog parks or areas like that. That's, you know, sort of an education component, I guess, of your program.
It's not been a significant amount, and just as much as where we've seen the human marker being less than 1, it's just as easily being a dog as some other type of mammal that's on there, which is one of the reasons why we've been trying to ask about markers for rats, but apparently there's not one that's available yet.
Right. Yeah. No, I think that's one of the challenges, finding the right markers to sort of get to what you're actually looking to answer in terms of your question. I I have a question that just came in about using optical brighteners as a tracker. So are you finding that optical brighteners help identify sewage sources that might not show up otherwise with ammonia, or are you primarily finding wash water?
Oh, no, I mean, no, we have found it, and it's been a good supplement. There's the occasional time. So just think about, it's not always a toilet that flushes, right? And the detergents that can come from a wash machine, from your kitchen sink, from even your shower. So we've had a few investigations by having the the fluorometer. So we use a handheld fluorometer, and having those optical brighteners have helped us to identify at least 2 illicit discharge locations since we've employed it. But we don't do it for every investigation. It's more of, we know something is happening, the bacteria is not there, but we have an idea that it is some type of illicit discharge that's related to sewage.
Great. And given the time, I'm going to go ahead and move us to one last question. Before I do that, I'm going to put the slide on our evaluation here so that folks can go ahead and fill that out. I'll put the link directly in the chat box, and I encourage you to, that way you can click directly on it. But the last question, and this is sort of a broad summary type of question, and I think you made a pretty good case for it, but maybe just to drive it home, the question is, do you consider a robust IDDE program a critical component to any urban bacteria TMDL program? Yes, 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 absolutely.
It also, I have to say, for field scientists, it's engaging. It's it's almost like our own detective show in a way, and it really it has helped us in some of the education ways as well, of just recognizing how we can actually improve some of our education messages by being able to have these different results and techniques in trying to communicate with private property owners. And it's helped us to also understand what else we need to look for during the construction process.
Great. Well, thanks again, Kim. I really appreciate your time. I think it was a great demonstration of, how to put together a good program that not only can address bacteria loads, but can really be streamlined or combined with your other ongoing efforts to try to make things easier, stuff that you're doing for nutrients and, and other priorities that you have in your city or municipality. So thanks again for your time, and I appreciate everybody joining us today, presumably from home. So, please feel free, like I said, I'll get this recording posted in the next couple of days, and feel free to share it with folks. We really appreciate it. And the survey link is in the chat, so you can link directly to it, and I really appreciate you taking the time to fill that out. All right, thanks everybody. Stay safe, stay healthy, and hope you'll join us again soon.
Bye-bye.